Thank you.
Hello, everyone. Welcome to Earth Sky's Monday live stream. I'm Will Triggs, and I am delighted to say I am here with Robert Reeves. Robert is a prolific astrophotographer, astronomy writer, and a certified lover of the moon. Thanks for being here, Robert.
Well, thank you very much for having me. It's always a pleasure to talk to anybody about the moon, and particularly a great organization like Earth and Sky. I'm delighted to be here. And you said certified lover of the moon. There is actually a word for that. It is called excuse me, that's Lover of the Sky is the name of our newsletter. It is um, um, selenophile, a person who
Mhm.
loves the moon. Getting my Latin terms mixed up there, but there's a term for us moon lovers, selenophile, person who loves the moon.
Well, I think you're going to all convert all to selenophile after this talk. And just last week, you released your new book, A Photographic Atlas of the Moon,
Yep, came out on
for all the
September
selenophiles out
1st.
there. hmm And some of the audience might be familiar with your daily postcard from the moon as well, where you highlight a different lunar feature every day. So, Robert, we thought we'd start by letting you talk us through a couple of your favorite spots on the moon. So, if we
Okay.
could have the first slide, please, Natalia.
Here it comes, straight wall.
There you go.
Now it's a straight wall, the black line feature, the diagonal black line. It's a rather steep slope on the moon. It's about 100 kilometers long. It's on the eastern shore of Mare Nubium, down in the southern part of the moon, and it's not a crater-like feature. It's not a mountain. It's a very unusual thing, and it quickly becomes um, both novice and experienced lunar observers one of their favorite things to see. Like I said, there's 30,000 craters visible on the moon through a modest telescope. So anything that's not a crater gets our attention. And a really neat thing about Straight Wall here is it's only been, in the past decade or so that amateur lunar photography has gotten good enough to really analyze this thing in detail. For centuries, since telescopic observation began back in the 1600s, we saw the straight wall as this shadow black line feature, or in the evening when the sun is fully illuminating it, as a white line feature where the cliff face is brightly illuminated. But now we see it in an entirely different light. Notice how straight wall is nested inside the arc of a crater that is partially buried under the basalt of Mare Nubium. It makes a kind of a horseshoe bay, and straight wall is nested in the middle of it. But look out further into Mare Nubium, see the wrinkle ridges arcing around, completing the circle of that original crater. Now, if that crater had formed a little bit further east, where it wasn't buried underneath lava flows, it would be among the 10 largest craters on the moon. But underneath it, there's still substantial volcanic activity happening um, many millions of years ago. So that volcanic upthrust forced up straight wall, the feature of it, and notice off to the left of it, on the other side of a little burnt crater, there's that long elongated rill. That was invisible to us until photography advanced to the point about 20 years ago where we could begin to resolve this. For decades, I observed straight wall, never saw that rill. But now it's a very common feature. If we don't see that rill, we throw away the picture because it's just not good enough. So now we have a better understanding of the formation of this whole area. Straight wall formed in the middle of this ghost crater, we call it, which is seen by the arc of the Horseshoe Bay and the completion of the buried rim of the crater underneath the wrinkle ridges. So it's a very volcanic region. Now that we see all of these features in one view, we can understand the dynamics of it.
So, I'm wondering, I think the tricky thing and the fun thing about the moon and observing it is trying to get some sense of scale. What would it be like to be standing by that wall if you could be there as an astronaut on the moon?
Okay, well, imagine it is now evening at this area, and the sun is going down in the west. You're standing on top of Straight Wall, and you're 400 meters above the plains in front of you. You know where Burt Crater is in front of Straight Wall, where that little rill is. The Wrinkle Ridge is further out, and you're looking out across this, and the sun is going down, and the shadows are coming towards you. Now remember, the moon rotates only about once a month, whereas the Earth rotates every day. So sundown on the Earth takes 2 minutes because the Earth rotates once a day. On the Moon, sundown takes an hour. So you have a long time to contemplate the beauty and the scale and the moving shadows and the dynamics of how the moon is moving, standing there on Straight Wall and watching the sun sink very slowly down below the horizon.
Wow, that sounds like an incredible sight to behold, for sure. And you mentioned looking at this in amateur telescopes and how that's improved. I assume this isn't a naked eye object, but how could people see this at home? With binoculars, would that be enough?
Binoculars works real well. Last night I was out at my observatory um, uh, doing some deep sky photography.
Okay, it's looking like Robert has just crashed, unfortunately. Um, let's just see if we can resolve this little issue. Um, bear with us. Sorry, everybody. Ah, and he's gone. Right, we'll be back with you just in a moment. And we'll be showing some more of Robert's photographs of the moon. Um, I was really enjoying hearing that first spot, and we've got a couple more to come from there. But let's just have a look and see if we can get Robert back in here. Bear with us. So whilst Robert is just rejoining, let's talk what we're going to talk about. We're going to have a look at another lunar spot, a few more craters. We're going to talk about some more ways to love the moon, even without a telescope, without binoculars, just going out every night and seeing the moon change its phases and recognizing that we have a 3D world out there, that it's not just this light in the sky, it is a whole world. And we'll be talking about some of the lunar missions that have been going on lately and soon to come. There's a big renewed focus on the moon coming up from NASA and from most of the major space agencies, really. And also, we're going to talk about some of the recent discoveries on the moon. As I mentioned, Robert is a prolific space writer, and he has been reporting on some pretty big recent discoveries of the moon over the last few weeks. And whilst we're waiting for Robert, I should also mention that his book, his latest book, A Photographic Atlas of the Moon, released on September 1st with Firefly Books. And here
Hello,
we
I'm
are.
back. My
Hello.
internet just flat shut down on me. I don't know what happened, but I'm glad to see that we're back.
We're back.
uh,
Don't worry at all.
you, oh, that scared me for a minute. Anyway, we're talking about this lovely view of Straight Wall and the perspective we have of the moon and sundown on the moon. And then um, I guess I'll blame it on sunspots. I lost my internet connection. So we can pick up from there.
Yeah. Oh, I think we're talking about binoculars. So you say binoculars,
Oh
you
yes, yeah,
can
that's
see
right.
this
I
quite
was
easily.
I was looking at the moon just last night. The beautiful crescent down in the southwest is seen from here in Texas, and through binoculars I could easily see the triple crater combination: Theophilus, Cyrillus, and Catharina. So even craters on the moon, you can see them in binoculars. particularly the craters that have rays around them. The impact that created these craters splashed out material in all directions, and it's still as visible on the face of the moon as these bright white rays. Like
Mm.
Copernicus in the Western Hemisphere, Copernicus and Kepler both have a ray structure that combine, and you can see them with the naked eye. And in binoculars, of course, very
Mm.
beautiful. And the same with Tycho. At full moon, you can look at the moon and see the rays from Tycho spreading across the southern hemisphere of the moon, and they all point back to Tycho. Now, Tycho is too small to be seen with the naked eye, but you can clearly see where it is because all the rays converge. And binoculars, you can see this very easily. So there's probably about 2 dozen features on the moon that you can easily see with a pair of binoculars, and it doesn't
Hmm.
take much telescope to really be able to enjoy the moon. At 50 power, the moon completely fills the field of view, and you can see all of the major craters. So a very modest telescope will give you much enjoyment on the moon. And I tell people follow the shadow. Follow the terminator as it progresses night by night and more of the moon phase appears, new features will appear. And right along that shadow terminator is where the detail is greatest because the shadows enhance the structure of the detail. At full moon, the moon is very flatly illuminated. There are no shadows. So a lot of these features will disappear. At full moon, you can see the dark maria, the uh, fields of basalt on the moon that fill the big basins that were created almost 4 billion years ago. And that creates the caricature of the face of the man in the moon. Very visible at full moon, but the small details that need shadows to create contrast, well, you don't see that at full moon. So it's always best, literally, to follow the shadow, follow the terminator, and see what's just emerging. That's where you see
Hmm.
your most interesting features.
Well, speaking of these craters that are especially good on the Terminator, if we could go to the second slide, please, Natalia, we can have. Yeah, here we are. So what are we looking at here, Robert?
Now we were looking almost right square at the center of the moon's disk. And the three craters on the left, Ptolemaeus at the top, Alphonsus in the middle, Arzachel at the bottom. Um, these are um, some of the oldest craters on the moon. Ptolemaeus, a huge crater, and you don't see any detail in the middle of it. The central peak is not there. The collapsed terraced walls, like you see on the very bottom crater of Arzachel, they've been completely obliterated by this wave of ejecta, the debris thrown out of the huge basin impacts almost 4 billion years ago. And that stuff fell into these craters and completely smoothed it over. Now, later forming craters that happened after that event, well, they do have central peaks and the terraced walls that are very common for a large crater. But Ptolemaeus is old, and it was pre-existing before these massive basin impacts. So its interior is completely covered over. But look real closely at the floor of Ptolemaeus. Notice the depressions in it, little dish-shaped depressions. One right above Little Ammonius crater, the only big crater on the floor of Ptolemaeus, and others easily visible down toward the lower left. These are what we call saucers. They're not craters. We call them saucers because they are so shallow. Now, what these are craters that formed on the floor of Ptolemaeus after its formation, but before the basin impact that filled it in. So once this wave of ejecta draped across the floor of Ptolemaeus, um, it didn't quite fill in these depressions, these pre-existing craters. So we have these saucers that are easily visible. And then you drop down to Alphonsus, and the middle of them. Um, at higher sun elevations, you can easily see at the 9 o'clock, 3 o'clock, and 5 o'clock position. You can see it somewhat in this image at the 5 o'clock position within the just inside the rim, dark patches of volcanic ash where volcanism was occurring in this area. And showering out volcanic ash that darkened the region around the vents. And then looking a little bit further down, further south, the Arzachel crater, um, a curious offset central peak, not right in the middle. A central peak on these craters is created by the rebound of the rock underneath the surface by the shock of the impact of the asteroid that strikes the moon. Uh, the uh, the impact of an asteroid on the moon is perhaps the most violent um, explosive event in the solar system outside of a solar flare on the sun. Um, One impact making one of these big craters just dwarfs the entire uh, nuclear arsenal of all nations in the world. So, an extremely violent impact, and the rock underneath the surface reacts in a fluid fashion and rebounds up like a trampoline and forms a central peak. And the walls of the crater, they're so tall, so big that they don't have the structural strength to support themselves. So they collapse and tumble down into the crater, creating the series of terraces. And that creates what we call a complex crater, as opposed to a simple crater, which is just a bowl shaped excavation like the many small ones that we see around the rest of the territory. They look like somebody took a giant ice cream scoop and just scooped out some of the moon. We don't have the central peak or the detail in the collapsed terrace walls. But another thing that is very curious about this particular image, notice that there are diagonal gouges from the upper left to the lower right all across the picture, all the territory. You can see these streaks. These were created by giant mountain-sized boulders that were thrown out of the Imbrium Basin impact about 3.8 billion years ago, and they tumbled out across the moon in all directions. And in this particular location, the orientation is that Mare Imbrium, the Imbrium Basin, is toward the upper left. So these mountains came flying out of the sky, crashed across the surface, and created these gouges. Now, officially, well, unofficially, we call these features the Imbrium sculpture because they were sculpted by these giant uh, mountain-sized boulders that were thrown out by the impact that created the Imbrium Basin. So that's uh, a very important geologic clue about how the face of the moon formed almost 4 billion years ago. And another curious feature up at the very top, just off the right side of the top rim of Ptolemaeus crater, see the row of very tightly packed craters, just all in a linear line. Um, the technical term for that is a catena. It's a chain of craters. Now, in this case, each of these craters was formed by the impact of a common object that broke up as it approached the moon and the sun and the Earth. Back 4 billion years ago, the moon was much closer to the Earth. It was when the moon was formed, it was no further away than today's geosynchronous satellites, very close. So the Earth-Moon gravity uh, combined would break up small asteroids and comets as they approached the Earth and the Moon. And instead of making a singular impact, they would rain down in a string and create these chains of craters. So this particular one we call Catena Mueller, named after Mueller crater up at the very top. So we see in this image clues of the formation of the face of the moon. We see how the giant impacts altered craters. We see how volcanism is visible in the craters. We see how the dynamics of how these craters form. So once you understand some very basic concepts about how these features form on the moon begins to take on a personality. It's not just a bunch of boring holes in the ground. Each has a story to tell. And if you understand the language of the moon, you can decipher these as you look at them through the eyepiece and understand their history and understand how the face of the moon evolved.
So we're looking at a pretty big range of impacts here. Some of these huge craters, then the pock marks. What kind of impacts would have been causing these different varieties? We had like sort of a meter wide asteroid coming into Earth's atmosphere the other day. What's the sort of scale we're looking at here?
Well, a meter-wide asteroid would probably just make a flash on the moon that is detectable from the Earth. This happens rather often. There's excuse me, there's programs where amateurs contribute where they look at the shadow side of the moon, the side not illuminated by the sun yet, uh, and just stare their camera at it, video camera at it, and record the flash, the very brief flash of an impact. Now, we know, of course, the moon is struck by meteors just as much as the Earth is, but the moon does not have an atmosphere. So these um, rocks strike the surface directly, and the kinetic energy of the impact vaporizes them, very high temperature, and we see it as a flash. Now, the um, curious thing about this is we need to characterize the impact rate on the moon. What's falling on the moon continuously? Because sooner or later we're going to have a base on the moon. We need to know what's going to be falling on our roof because we're going to be living there. So amateurs are able to contribute to the understanding of this by submitting their observations, their videos of these impacts. The um, Marshall Space Flight Center at Huntsville, Alabama, has an ongoing program studying this. And if we're going to live on the moon, we need to fully understand this so that we can protect our future habitations on the moon. That's why we're looking more and more toward this concept of putting a habitat on the moon in a underground lava tube, which automatically protects you from the smaller impacts. Of course, if a mile-wide asteroid hit it, all bets are off. But we're talking about the very common fist size, arm load size rocks that slam into the moon every day. So these are the ones we need to be careful about. So
So in terms of these, so obviously they're quite common, these smaller impacts, but
mhm.
the big craters that we see on the moon, are there any that are fairly modern within quite a wide span, or is it quite a long time ago that these were all caused?
The majority of the ones we see were created literally billions of years ago, but as the solar system evolved and got older, more and more collisions occurred, and while there's still thousands of asteroids out there that could hit us, um, the solar system has used up a lot of its ammunition. It's already impacted. So the impact rate today is about 300 times less than it was back when the moon formed. And thank goodness, because if the Earth were peppered as often as it was back then, life as we know it would not have evolved. We'd have extinction event after extinction event. But on the moon, you can see the craters that are younger than a billion years because they still have rays. Crater rays will fade after about a billion years by the continuous gardening of the soil by meteorite impacts, and it erases the white ray structure. So you look at Copernicus crater. It's between 800 million and a billion years old. Kepler, about half that age. Look down at Tycho. We're reasonably sure that Tycho is only 108 million years old, as dated by some samples returned from the Apollo missions. So basically, Tycho formed. When it formed, it probably startled many a T-Rex here on Earth with a brilliant flash of the impact. Because back by then, only 108 million years ago, uh, the moon was already tidally locked so that it kept the same face toward us. So the location of Tycho now is where it was at the time that it formed. So it was a very visible um, uh, impact as seen from Earth. But of course, no humans were there then. But like I said, it probably shook up quite a few dinosaurs.
Right, right. And when you talk about rays, we're talking about these lines that emerge from these impact craters, right? And
Right,
so
right,
you can look up at the moon without magnification and you can just about see the latest craters on the moon.
right. Tycho crater itself, the most recent one, is very visible with the naked eye at full moon because you can see the ray structure fanning across the entire southern hemisphere of the moon. And in binoculars, it
Right.
shows up really well.
Right, okay. So that's something to look out for. And well, speaking of which, Obviously, learning about these amazing close up geological features is one way to appreciate the moon. But what are some other ways people can learn to really love the moon, maybe without binoculars, without a telescope, but just by going out into the night sky?
Well, the moon is a naked eye object, of course. I mean, it's a half a degree in diameter. Um, I mean, it's a substantial size object in the sky. You can easily see the phase, the crescent, the quarter, the gibbous phase. One thing that I really enjoy is right after new moon, when the moon is still a crescent, and low in the western sky after sundown. Often you can see the entire globe of the moon very faintly glowing. You see the crescent illuminated by the sun, but the rest of the moon is also visible by sunlight that is reflected off of the Earth and bounced back to the moon. Now, at this point, the entire moon being illuminated very faintly, we call that effect the new moon in the arms of the old. But
Right.
the crescent moon itself during that phase, I like to call it the Cheshire Cat moon. Because remember the
Hmm.
tales of the adventures of Alice in Wonderland, where the Cheshire Cat would slowly fade away until only a smile left? Well, that's what the crescent moon looks like to me. The Cheshire Cat has faded away and his smile is still up there. So, observing the moon naked eye, like I said, as the phases progress toward full moon, you can visually see just with your eye the bright ray structures of Tycho, the bright ray structures of Kepler and Copernicus combined. These make a bright spot on the uh, upper left side of the moon. You can see the dark regions on the moon. We call them the Maria, the Lunar Seas, even though they're really basalt. And these um, dark regions form a caricature of a face. We call it the man in the moon. Mare Imbrium makes the left eye. Maria Serenitatis and Tranquillitatis make the right eye. Uh, Nubium and Humorum kind of make his offset uh, smile. He's kind of smirking at the earth a little bit. Uh,
Right.
yeah, Mare Vaporum in the middle makes his nose. And if you have really good vision, Mare Frigoris, a very unusual sea in that it's only about 150 kilometers high, but it is almost 1,500 kilometers wide. And it arcs over the top of the moon and creates the eyebrows above the man in the moon's eyes. And you can see these with your face, with your naked eye, and see this face, and it gives the moon a personality. It's not just this bright light in the sky. Many um, hardcore deep sky astronomers who love to observe galaxies and nebula complain about the moon being in the way. Too bright a light gets in the way.
Hmm.
Well, I say the moon is not a target to be avoided because it interferes with the deep sky. It's a target to be embraced when it is there because you can see the moon from your own backyard at home. You don't need to go out of town to a dark sky to see the moon. The moon laughs at light pollution. It will shine through no matter what from the brightest city. So uh, you have a telescope, even a most very modest telescope, point it at the moon. Get to become friends with the moon, understand it. There's um, literally thousands of years of interaction with human culture in the moon through mythology, through prose and poetry. Um, uh, just thousands and thousands of works of great literature inspired by the beauty of the moon. So it's been intertwined in the soul of mankind for well since we were cavemen. Uh,
Absolutely.
so
Yeah. And you mentioned the face on the moon that is made up by these maria, these seas in Latin, because originally that's what observers thought they were, right? But actually,
right.
it's lava pools or solidified lava pools.
Yeah, that's correct. Now, early on, when um, the Greeks and the Renaissance astronomers, pre-telescopic era, well, they assumed the moon was like the Earth, and the dark regions were indeed oceans. And um, once the telescope was perfected enough to realize that no, that's not water. We maintain that tradition of calling the lunar seas, although uh, we know they're not. I mean, they're solidified fields of basalt that were deposited in these giant basins, just giant craters. A basin is nothing more than a crater that is larger than 300 kilometers in diameter. So these giant asteroid impacts gouged out these basins and they filled in with basalt and created the face of the man in the moon.
Right. And people might be surprised to think of lava on the moon, possibly, but obviously it was once volcanically active.
Oh
And
yeah,
I think I was
very,
reading
very.
about your research lately. It's actually much more recent than we'd think. Is that right?
This is true. Now, the moon has been volcanic, of course, early on because it was formed about 4.6 billion years ago, and early on it was in a molten state because of the ferocity of the impact that created the moon and tore it away from the Earth. Um, and it cooled down, and about 3.8 billion years ago, more massive impacts on the moon created the basins, the Great Basins, and then for the next billion years, volcanic eruptions slowly filled in these basins to create the face of the man on the moon. And we assume that volcanism continued up for another couple of million years because we can see how it modified existing craters. There's a whole class of craters called floor fractured craters that are volcanically modified. And this went on for several billion years. And then finally, we get to the Copernican epoch, the modern era of the moon, from about a billion years ago till now. Traditional thinking was that volcanism had essentially ended by then, but now we're finding evidences that uh, the Chinese Chang'e 5 lunar lander that landed on northern Oceanus Procellarum in 2000. Examining soil samples of that, they found volcanic glass beads, which were essentially volcanic ash blown out of a volcanic vent that are only 125 million years old. Now, 125 million may sound like a long time ago, but considering the age of the moon, that's only 2.5% the age of the moon. So that establishes that the moon has been volcanically active for at least 97.5% of its lifetime. So one and 125 million years ago, geologically, that's just the blink of an eye. So
Right.
we can essentially say the moon has been volcanically active its entire life. And if it was active just that recent, um, it points a finger at the need to really research this deeper and see, what is going on in the interior of the moon. Are there still magma chambers under there that could erupt in the future? And
Right.
this kind of research is going to be coming up fairly soon. Instruments are going to be flown to the moon in the next several years that will probe the interior of it and come up with answers to these questions.
Well, let's talk about that because it's been a big renewed focus on the moon in the last few years from lots of space programs, China, Japan, India, the US, all landing on the moon in the last year or so. And then, of
Yeah,
course, the big one
absolutely.
coming up, the Artemis program. Can you tell us about that one?
Well, Artemis, the American manned landing program to return to the moon, it's been kind of a start-stop affair over various presidential administrations, but it's finally gotten enough inertia that progress is being made on it now in the early 21st century. Um, uh, there's been various arguments about how to get to the moon. The um, giant rocket that NASA is making, the Space Launch System, it's enormously expensive per launch, $2 billion just for one launch. So cheaper ways have to be perfected. And of course, we're all looking to SpaceX to perfect their Starship. That would be an enormous game changer in being able to um, have an economic access to the moon and the lunar surface. And of course, China is very determined to return to the moon. The history of the Chinese space program is when they say they're going to do something, they end up doing it. That's not just a bunch of uh, speculation. it sometimes takes a few years longer, but they eventually do it. And they are very adamant that they are going to the moon, looking to the 2030s for a manned landing on the moon. India looking a little beyond that. India has an indigenous space program that has developed some very uh, uh, good boosters. They don't have a giant heavy lift booster yet, but give them time. The Indian space technology is doing very well, considering that India was just barely removed from being a third world country when Apollo 11 landed on the moon, and now India is taking the forefront in some of the lunar research. So a very technically capable country with very bright people, very interested in space, very interested in technology. So um, if NASA and the American government doesn't um, kick it up a notch with the Artemis program, we may be riding Indian and Chinese coattails to the moon. So
Right.
it's a very distinct possibility. But both China, India um, have excellent, very active space programs, and of course Japan as well. Um, Japan uh, is one of the other nations that has landed on the moon. Their probe earlier this year, unfortunately, fell over on its side. But then again, our own did that as well last January, or February. Um, the first lander that made it to the moon under the CLIPS program, the commercial lunar program that NASA has, it toppled over as well. So even half a century after the success of the Apollo, the moon is still very much a harsh mistress. Getting to the moon is hard. Landing on the moon is not easy. This is not an airline reliable process. We're still in the baby steps of learning how to do this reliably and getting it done cheaply so that it will be both a scientific and a commercial success in the long run.
Absolutely. Yeah. Well, when you look up at the moon tonight, as I'm sure you shall after all these great tips, just think about that. In maybe a year, maybe a couple of years, we could be seeing certainly humans orbiting the moon and perhaps a lunar base in the next
Yeah, next year
two or
we
three
will
years.
have the next manned lunar flight looping around the moon. I'm sure
Mhm.
that's going to go off fairly well on time. But exactly when the next human footprints are on the moon, the crystal ball is cloudy on that. But I'm sure it
Yeah.
will happen before the end of this decade.
Great. That's something to look forward to. And well, I think that's all we have time for. Thank you so much, Robert. It has been wonderful to talk to you. And yeah, I think we're all going to be looking out at the moon tonight.
Um,
So thank you. Where
you
can
bet.
people find you online, and where can they find your latest book as well?
My latest book, Photographic Atlas of the Moon, it's available on Amazon and at any major uh, Barnes and Noble type book outlet. It is available in brick and mortar bookstores as well. Some people have ordered it on Amazon, received them immediately. I'm hearing reports from others that there's various delays, but Firefly has sent Amazon their shipment. Amazon is a law unto itself. How it distributes it is a bit of a mystery. Some people get it quick, some people are or there's delays, but it is in the pipeline. If you order it on Amazon, you will get it. If,
Brilliant, and well worth it
bookstores as well.
because the photos in there are absolutely amazing, and you've seen a couple today, and the rest of the book is chock full of photos like that and wonderful descriptions. So do look for that, and please do subscribe to us here on YouTube and click the bell to get notified when we post. We've got more exciting live streams to come every Monday and Friday at 12:15 Central, 17:15 UTC. Friday is our weekly Sun News update with heliophysicist C. Alex Young. And then 1 week today, we'll be talking to astronomer Jonathan McDowell about the
Mm,
potential consequences of the Space Race 2.0. So that's going to be a good one. We hope to see you then. Thank you again, Robert. And thank you guys for joining us. See you
bye
later.
bye.